Related rates. So we're going to jump right into it, guys. Related rates is just like implicit. The only difference is we're not taking a derivative with respect to x. We're taking a derivative for the most part with respect to t, time, because now we're working with real life questions, with real life scenarios. So check it out. So example one. Assume that the radius r of a sphere is the differential function of t and let v be the volume of a sphere. Find the equation that relates dv dt and dr dt. The hardest part of this is if you remember the volume of a sphere. Do you remember how to get volume of a sphere? You can be honest. No. What is it? No, I think you got it right. What is it? Yes. How'd you remember that? You must be a genius. 4/3 pi r cubed, guys. That's from your geometry days. That's the volume of a sphere. So they want me to. What does this dVdt mean? The derivative of volume with respect to time. So I'm just going to take a derivative with respect to time. So here we go. dVdt equals. Tell me what the derivative of 4/3 pi r cubed is. 4 pi r squared, but I didn't take the derivative with respect to r. So what do I put right next to it? dr dt. I took that derivative with respect to time. So there it is, and that's it. That's the hardest part, guys. Don't worry. Right now we'll use an application. A cone. Do you remember what the volume of a cone is, Miss Konduru? Can you tell us what the volume of a cone is? You remember this one? Pi r squared times height. You're close. Something's in the front. Pi r squared times height. Not 1/2. 1/3. If you Google, maybe you'll see that one, or maybe you'll see this one. It doesn't matter. They're both the same, guys. They're both the same. Now, you can group the pi over 3 with the r, or you can choose to leave it. Most textbooks are probably going to do this. So we're taking a derivative. dv dt equals, most textbooks will probably leave the pi over 3 alone and just work with the r squared h. So here's my pi over 3. What rule do I need for the r squared h? Yeah, product rule, guys. So what? Tell me. So you guys guide me. What do I write? What do I type? First, so r squared dh dt, derivative of the second. Not everyone at the same time, guys. Plus h times derivative of the 2r dr dt. Close. Look at that. And that's what it is our first time doing these. How are you so good? Because it's the same as implicit. The only difference is that you're putting in a t. So everything's going to have a t, guys, because you're taking a derivative with respect to time, and none of these have the variable t. So there it is. Sometimes you want to, traditionally, you want to put it nice and pretty. Chav, how do you put it pretty? Well, I guess technically, when you open up a textbook, you see letters all over the place. You usually put it in alphabetical order, but it doesn't have to. It doesn't have to. So you don't have to put it in alphabetical order. That's just what most authors do. Cool or not cool? All right. There it is, guys. So now we're going to put it into practice, see if we can do a real life situation. All right. So here we go. Example 2. A spherical snowball is melting in such a manner that its radius is changing at a constant rate, decreasing from 21 centimeters to 10 centimeters in 30 minutes. Okay. At what rate is the volume of the snowball changing at the instant the radius is 3 centimeters? What do they want? What is this? At what rate is the volume of the snowball changing? What does that mean? The rate of change of what? Of okay, the melting. So what is, if it melts, it's going to be the what? Starts with letter V. The volume. So they want dV dt. That's what they want. You already know the volume of a sphere is 4/3 pi r cubed. So we're going to write dV dt equals 4 pi r squared. Am I done? Oh, yeah. dr dt on the side, guys. Yay or nay? No, tell me, because I can't. Guys, tell me. What's going on? Say it again. Because I'm taking the derivative with respect to what? Time. So I have to anything every variable is not going to have a t, so I have to add it for all of them all the time. Cool or not cool? Now this radius you have, the radius is 3 centimeters. Guys, the drdt, you have it. You have it. But you just don't know you have it. Look, it's right here. I go from 21 centimeters to 10 centimeters in 30 minutes. So that means your drdt, it changes. Let's see, what does it go? Negative, the difference between 21 and 10 is a negative 11. So it changes negative 11 centimeters in 30 minutes. So your drdt, let's write it better. drdt equals negative 11 over 30 centimeters per minute. Does that make sense, guys? Yeah, it's a rate of change, but they told us it was a constant rate, so it's constantly changing at that rate. So here we go, guys. My dVdt is nothing more than 4 times pi. Okay, here we go. 4 times pi times the radius squared, so 3 squared, and then the drdt, negative 11 over 30. So let's see, 3 squared is 9, 9 times 4 is 36. So 36 pi times negative 11 over 30. Man, I don't know what that is. So let me just take my calculator. So I'm going to go 36 times negative 11 over 30. So I'm going to go 36 times, no yawning. That's a demerit. 11 over 30. Close it. Enter. Math, fraction, enter. 66 pi over 5. Negative 66 pi over 5. Let me make sure that I did everything right. 36 times 11 over 30. Yep, negative. Okay. And I need units. Cubic centimeters per minute. Yeah, the units make sense. This one's r squared, so square centimeters, times this one's in centimeters per minute, so cubic centimeters per minute. Sorry, I want to yawn and try not to yawn. How do we feel? Do we feel good, Ms. Monte? Oh. All right, here we go. Example 3, a highway chase. This one's fun, guys. A police cruiser approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. So the hardest part is creating a model. When the cruiser is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determine with radar that the distance between them and the car is increasing at 20 miles per hour. Okay, so I see a right triangle. North, south, east, west. If the cruiser is moving at 60 miles per hour at the instant of measurement, what is the speed of the car? Okay, north, south, east, west. I'm going to say north is this way. South is this way. East is this way. And west is this way. Just a compass. Remember, guys? Okay, I want to make sure that we know. So, because I don't want you guys to be a robot. So look at this in blue. This is my X. This is my Y. If I move to the right, it's positive. If I move to the left, it's negative. If I move up, it's positive. If I move down, it's negative. No more yawning. The next one, whoever yawns next, I'll stop. All right, here we go. Here is the cop car. I wanted to be a cop when I was little. I don't know if you guys know that. And here's the bad guy. Because it says it's moving east. So there it is. It's moving east. So I'm going to say this is X. I'm going to say this is Y. Here's the radar. I'm going to call it Z. So let me put here on the side what we know. What do we know? The police cruiser is 0.6 miles north of the intersection. So Y equals 0.6. Okay, timeout. Do not do this, guys. I mean, maybe it's, okay, depending on who you get. If you put 0.6 here like that, that means that it's always 0.6, no matter the time. So if you do that in physics, your professor will probably frown and count it wrong. If you do it in math class, they'll count it wrong. Well, it depends. Maybe the professor's cool and he'll be like, we don't care. You need to put a variable y because y is changing. It's not 0.6 forever. It's just 0.6 at a moment. Does that make sense? Okay. X is 0.8. So do not write 0.8 here unless it's static. And I don't know what z is, but we can find it. Let's see. What else do I know? With radar, the distance between them and the car is increasing at 20 miles per hour. That is dz/dt. 20 miles per hour. Let's see, what else do I need? Okay, there it is. That's it. Well, we'll figure out what we need in a little bit. What connects all three of these variables? X, Y, and Z. There's a formula that you learned in geometry. Yeah, what's the name of that? What's the name of that theorem? So Pythagorean theorem, x squared plus y squared equals z squared. Are we okay? Here we go, guys. I'm taking the derivative with respect to what? Time. 2x dx dt plus 2y dy dt equals, I'm taking the derivative with respect to time. Not with respect to x or y, but t. You're like, huh? Let me repeat what you did. You're like, huh? That was funny. Sorry, YouTube. I am not making fun of my kids. Equals 2z dz dt. You're fine, miss. We don't bully here. I've never bullied anyone. Never bullied a single one of you guys. All right, here we go. We're done. Look at this. What do we know? Do we know the x value? Yes. We don't know the dx dt. That's what we're looking for. We know the y value. We know dy dt. Well, yeah, we do because he's moving. Man, why didn't I put that in here? Dy dt equals, he is moving at 60 miles per hour. Where are you? I remember reading 60. Yeah, the cruiser is moving at 60 miles per hour. So since he's going down, I'm going to say negative 60 miles per hour. And do we got z? Yes, we do. And, well, not directly, so I'll put an awkward emoji. We have dz dt. Okay, Chav, how do we have z? I don't get it. Look, you have x and you have y. We can just use Pythagorean theorem. So you're going to go 0.8 squared plus 0.6 squared. We're taking respect to t. Okay. We're okay? We're okay. 0.8 squared is 0.64. 0.6 squared is 0.36. Where did I confuse you? Because I need. I'm moving down.
It's just like what?
I'm moving down, miss. This cruiser is going this way.
Well, I know it's negative.
Yeah. Because I'm moving down. This is why I did this in blue here. To input. Yes, dy dt is negative.
It's the derivative of y.
Yes. Yes.
Because
Because it's a speed. It's a rate of change.
okay. Oh,
Right.
speed is rate of change.
Yeah. 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 I mean, I'm not so right all the time, but I'm so right now. All right. So here we go. Yeah, I didn't mean to say that. Sorry. That's kind of sassy, right? I didn't mean it. 1 equals z squared. Sometimes I have trouble adding decimals, but right now I seem to be adding okay. Square root, z equals 1. You guys already knew that. So there it is. I'm just going to plug it in. So I'm going to write 2 times. Actually, I already started. I'm going to say factor out of 2 and cancel all of the 2's out. Okay, let's do it. There's my 2 factored out. X dx dt plus y dy dt equals 2z dz dt. If I divide both sides by 2, these 2's go away. Do you guys see that? Okay, now I'm going to plug in. So let's see. X was, what was my x? 0.8. So 0.8 times dx dt, which we do not know, plus my y, which is 0.6 times 60 negative 60, equals z, which is 1, times 20. There it is. So 0.8 dx dt plus, let's see, 60, so that's like 6 times 6, so negative 36. Negative 36 equals 20. Are we still okay? You're done with calculus, guys. You were done with calculus right here, really. Now it's just an algebra game, right? Move the 36 to the other side. 0.8 dx dt equals 36, 46, 56. 56. Well, I don't know what that is divided by 0.8. Divided by 0.8, dx dt equals 56 divided by 0.8. Let's see what that is. I can't do it on the top of my head. Oh, yeah, wait. 8 times 7? 8 times 7. Okay, so it's probably 70, right? 56 divided by 0.8. Yeah, 70. I could have done it. Sorry. Miles per hour. Now you're seeing how practical these related rates are.
We're in the back.
Do you guys remember Castillo from the class of 23? 23. Emilia? She sent me, she's doing something in chemistry, and there was like a rate of change of some chemical reaction, and she had to do calculus, and she sent me that, like, look, calculus in chemistry. It's everywhere. So, well, if you're in engineering school, you're going to see it all over the place. You're going to be doing 4 years of calculus. So if you go to engineering school, you're going to come back a calculus boss. All right, here we go. Yeah, for everything. For circuit analysis, statics and dynamics, the force of so you're going to be doing nothing but calculus all the time. All right, here we go. A rising balloon. A hot air balloon is rising straight up. Oh, that's cool. Have you guys ever seen a hot air balloon? Here we go, guys. Here we go. A hot air balloon rising straight up from a level field is struck by a rangefinder 500 feet from liftoff point. Okay, that's 500 feet is static. That's always 500 feet, so that is okay to draw on your picture. At the moment, the rangefinder's elevation angle is pi over 4. That's your angle. So theta is pi over 4, 45 degrees, but you're not working with degrees. You're always working with radians. The angle is increasing at a rate of 0.14 radians per minute. So d theta dt equals 0.14 radians per minute. How fast is the balloon rising at that moment? Draw a picture. That way you don't get it wrong. So here's my picture. Here's that dot is your pathfinder or your track, the whatever this is, the rangefinder. And here's the ground. It's flat. And here's the hot air balloon. And I'm going to say this is height. So there's my right triangle. And theta. And this is 500 feet. Okay, love it. I love it. What are we looking for? The rate of change of how fast the balloon is moving up. So that is what? If I put this as h, dh dt, that's a speed. See, dh dt, how fast something is moving. Up. Ask me, Lopez. This is my hot air balloon right here. And this hot air balloon is moving up like that. So I'm looking for DHDT. How fast I'm going. Okay. Ask me, Rodriguez. Yeah, okay. All right, here we go. You guys all took pre-cal. You guys all took geometry. I know, guys, it's the end of the day and we're tired, but I'm still wired from that coffee that I took during lunch. So yeah, you're getting me all wired right now. All right. With respect to that theta, what connects the theta, the h, and the 500 from your pre-cal days or your geometry days? Oh, yeah, Pythagorean theorem does also. I want to use the theta. I want to use the angle. I could have used Pythagorean theorem if I knew like the hypotenuse, like how fast the rate, but I want to incorporate my theta. So you use sine, cosine, or tangent. Which one uses the h and the 500? Tan. So that's the one I'm going to use. Really, you could have used any of them, but why complicate things? Just use the static number there. So, yeah.
What saying do you use for SOHCAHTOA?
Well, what?
What saying do you use
Oh,
for
miss. We're good. I just say SOHCAHTOA. So, yeah, like, yeah. Come on, don't worry about it. All right, guys, here we go. Tan theta equals, all right, guys, focus. Opposite over hypotenuse. Are we still okay? All right, next. You're looking for DHDT, so usually you want to get H by itself. This one's a pretty simple one to get H by itself, times 500 both sides. So I'm going to write the H on the left-hand side. H equals 500 tan theta. Are we okay? All right, next. Here we go. All I'm going to do now is just take a what? With respect to what letter? No. T. With respect to T. We're not doing implicit here. So here we go. dH dt equals, what's the derivative of tan? Secant squared. Now, I took it with respect to T, not theta, so what did I put right next to it? D theta dt, because it's a theta. I took the derivative of theta with respect to T. I guess you could also think of that as chain rule. I'm taking the derivative with respect to T. That's not a T, that's a theta. So you got to put d theta dt. You can also think of this as chain rule. Leave the inside alone. Derivative of tan is secant squared. And look, the inside is theta. And then what's the derivative of theta with respect to T? D theta dt. No, we're taking the derivative. We're taking the derivative with respect to T. So you can think of it as chain rule. See how it all comes back? It's all the same. Cool or not cool? All right, check it out, guys. Here's why pre-cal is important. Look, theta's pi over 4. So they're being nice to you. Child, why are they being nice? Because at pi over 4, x and y are both square root of 2 over 2. So there's no way you can mess up, even if you don't know. There's no way you can mess up. I don't remember what cosine or sine of pi over 4 is. Well, it's the same. Right? They're both the same. So look, here it is. dH dt when theta equals pi over 4. You don't have to put that, but it's nice if you do. 500 parenthesis secant the reciprocal of cosine. And cosine is square root of 2 over 2. So I'm going to write it as 2 over square root of 2, close it squared. Is anyone confused by that? Oh. Times, what's d theta dt? Not everyone at the same time. 0.14. All right, here you go. Here's the answer. 500. 2 squared is 4. Square root of 2 times square root of 2 is 2. 4 divided by 2 is times 0.14. I always mess up right here. Let's see. 1,000 times 0.14. Move the decimal. Let's see. So that's going to be, is it 140 or is it? Yeah, 140. So there it is. And I need units. Feet per minute. Okay, time out because you guys are going to. All right. I'm going to give you guys, again, a question very similar to this on the exam. And some of you guys are going to tell me something ridiculous like 3,500 feet per minute. It's a hot air balloon. It's a hot air balloon, guys. You're not going at like 1,000 miles an hour. So 140 feet per minute, if you divide that by 60, because there's 60 seconds in a minute. So let's see what that is in a minute, like in a second. 140 divided by 60. So you are climbing, let's see how fast it's climbing. You're climbing 2.333 feet per second. Yeah, that sounds about right for a hot air balloon. 2.3 feet per second, you're 2 feet a second? Yeah, that sounds about right. Now, if it's doing 1,000 feet a second, guys, a hot air balloon is not going to be going that fast. Do we understand? Like, make sure that the numbers make sense. That's how accidents happen. Even engineers have made mistakes like that. All right. We're in Texas, so we should know what a conical tank is, right?
Oh, the thing.
Yeah, sometimes they have wheat on it, and there's a truck goes under, and then they pull the lever, and then a conical tank, and it pulls. You guys ever work on a farm before? No, no. Oh. I mean, yeah. Here we go, guys. Here we go. Focus, 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 guys. We're almost done. Water runs into a conical tank at a rate of 9 cubic feet per minute. So what is that? Tell me what this is, like in terms of symbolic representation, in terms of symbols. Yeah, 9 cubic feet per minute. But I want to know, like, is it DRDT? Is it DADT? Is it DVDT? Like, yeah, this is volume, cubic feet per minute. So this is DVDT. Yeah, cubic feet is volume. Yeah, this is just the rate of change, guys. Just all right. Time out, guys, because I fear that some of you may be becoming robots. Remember, guys. Look, guys, focus, focus, focus. The dV just stands for the change in volume, but we're talking about at a moment. So, what's the difference between triangle and DVDT? The DVDTs are at a moment, instantaneous rate of change, infinitesimals. The change in volume over change in T, that's like an average rate of change. So this is at a moment. Yeah, at a moment. So here we go. So 9 cubic feet per minute. So that's at a moment. The tank stands point down and has a height of 10 feet and a base radius of 5 feet. Of course. Hopefully you've had some experience because we're in this lovely state of Texas and you've driven past some conical tanks in reverse. Okay, next time when you're driving or you're driving through the state, look at the silos and then like the way they feed them into trucks. They're kind of like the silos are connected to like conical tanks. Right, look, right now we'll Google so you guys can see. Just Google conical tank in farm. Put farmland conical tank or something. All right. How fast is the water level rising when the water is 6 feet deep? Let's draw a picture. Here we go, guys. Let's draw a picture. Let's see how it looks. Does it look awesome? Yeah, a conical tank. It's a cone. Yes. Oh. Never? But did you just Google how it looks? And now you've never seen them driving through little towns? Oh, okay. All right. What is the height of this conical tank? So this is okay to write 10 feet because that tank is not changing heights. The base radius is 5 feet, so this, to put a 5 right there, is perfectly fine. That is not changing. If it is, we have issues. Yeah, it's a tank. It's a metal tank. It should not be changing heights. The radius should not be changing. All right, now there's water in this tank, and the height, let's use blue for water. So the water is right here. Here's the water. And I'm going to draw this height there, and I'm going to draw that radius. I'm going to put R, and I'm going to put H. That is changing, so that's why I wrote R and H. Are we okay so far? All right, so let's write what we know. We know dVdt is 9 cubic feet per minute. What else do we know? We know that the height of the water is 6 feet deep. So H is 6 or 6 feet. Let's see. What else do we know? I think that's it. It tells you right here. How fast is the water level rising when the water is 6 feet deep? Last, what do they want? How fast the water level is rising. If I call this H, then they want dH dt. Question mark. Here we go, guys. Volume. Pi over 3 R squared H. I'm going to take a derivative. dV dt. You can pair it with the R squared, but I just like to factor it out because it makes life a little easier when you're doing calculations. First times root of the second plus second times root of the first. You can distribute the pi over 3 if you want, but trust me, when we're plugging stuff in, it makes life easier like this. All right. Next. I guess next what we got to figure out, let's see, what do we want? We want dHdt. I'm going to put check marks and X's on what we have and what we don't have. dVdt we have. The radius we don't have, but we can get it. So I'm going to put an awkward emoji. dHdt, that's what we want, X. Height we have. The radius we don't have, but we can get it. And the drdt, we don't even want that. We don't have it. I want to get rid of the drdt. Get rid. How am I going to get rid? No, not get riz. Get rid. Here we go, guys. We want to get rid of the drdt. So here's where we're going to use geometry. Do you see the blue triangle here? I guess let me do it in green. Do you see the green triangle right here? Do you guys see it? Now look at the purple triangle right here. Do you guys see this purple one? We're going to do proportional triangles just like you did when you were in geometry. So here it is. I'm going to write it like this. 10 is to 5. That's the big one, right? The big triangle. This is the purple. So 10 is like H, as H is to R. I'm going to cross multiply. 5H equals 10R. And look what it says here. It says get rid of drdt. So I'm going to get R by itself. So R equals 5H over 10 over 10, which is half H. I'm going to take a derivative. dr dt equals 1/2 dH dt. That's what I'm going to plug in right there. So I can have just in form of dH dt. dV dt equals pi over 3 bracket r squared dH dt. What do you mean? When I did product rule, I took the derivative of r with respect to t. So that's why I put 2r dr dt. Oh, well, r equals half h, right? So I just took the derivative. dr dt equals 1/2 dH dt. Cool, right? So r squared dH dt plus 2hr, and then I'm going to write what dr dt is, times 1/2 dH dt. Close bracket. 2 and 1/2 go out. And now you have this. dV dt equals pi over 3, that's a 3, r squared dH dt plus hr dH dt. Now we can start plugging stuff in. But we still don't know r. Yeah, we do. R equals half h. What was h? What's half of 6? R is 3. We're plugging in now. So I'm going to zoom out so I can see my stuff. 9 equals pi over 3, bracket. R was 3, so 3 squared dH dt plus h, which is 6, times r, which is 3, dH dt. Okay, let me close the bracket and let me zoom in. All right, we're done, guys. We're just doing algebra now. Hopefully your algebra skills are getting better because of all this. 9 equals pi over 3, bracket. 3 squared is 9, so 9 dH dt. Plus 6 times 3 is 18, dH dt. Combine like terms. 9 equals pi over 3. And look, that's a dH dt. That has a dH dt. 18 plus 9 is 27. Oh, I'm multiplying it by pi over 3. Okay. 9 equals, I'll slow down. 27 divided by 3 is 9. So 9 pi dH dt. Does everyone know how I got the 9 pi? Yeah, times 1/3 or times pi over 3. Divide by 9 pi. dH dt equals 1 over, well, I guess I'll show first. 9 over 9 pi, which is 1 over pi. And I need units. What are my units? Feet per minute. Ask me, Salali.
No, I just forgot about our notes at the top. Like you pants the left, I see 9, and I haven't had to put in 9 this whole time.
That's fine. You can write DVDT there the whole time and then change it at the very end. How do we feel, guys? All right. Hopefully you're seeing that it's not that bad. Is there another way to do example 5? Yes. Don't worry, there's the last one. Look, here's the other way. Volume equals pi over 3 r squared h. And I'm going to write, we want the h dt. Guys, if we want the h dt, just get rid of r. Get rid of quote unquote r. How do we do that? From your similar triangles. From right here. From right here. Let me draw it again. R, H. Remember that this distance here is 10, and then this distance here is 5. So from similar triangles, 10 over 5 equals H over R. So then look, you can just do this. 10R equals 5H, just like we did earlier. Divide by 10, divide by 10. R equals H over 2, or 1/2 H. That's it. I'm just going to replace it. Volume equals pi over 3, parenthesis, H over 2, close it squared, times H. Volume equals pi over 3, parenthesis, H times H is H squared. 2 times 2 is 4, times H. So finally I have pi over 12 H cubed. Now look, guys, that's it. We're done. Let's see if we get the correct answer. Let me rewrite it, guys. Pi over 12 H cubed. I don't see any errors. Let's take a derivative. dv dt equals 3 pi over 12. Yes, I'll reduce it right now. H squared dh dt. Look how simple this is, guys, or how much simpler it gets. 3 goes into 12 4 times, so let's rewrite it. dv dt equals pi over 4 h squared dh dt. Let's plug in. dv dt was 9. H was, what was the height again? 6. And that's all I need. So 9 equals pi over 4 parentheses 6 close it squared dh dt. 9 equals 6 squared is 36. 36 divided by 4 is 9. So 9 pi dh dt. Oh, look. dh dt equals 9 over 9 pi, which is the same as 1 over pi. Feet per minute. Same answer as before. Which one do you like better? Cool or not cool? I think we cooked. Did we cook? All right, so here's what the plan. Here's the plan. Relax, relax. We're already done, guys. We have a simple delta math. Of course, it's going to get harder. But right now, I just put the level 1 questions. We will have a handout, but I don't want to give you... Look, guys, I thought about mental health. I could have given you guys a handout today, but I said no. They already have a lot of work. So I didn't give you guys a handout because I don't want you guys to take home work. If you're fast enough, Delta tells me that it should take about 40 minutes. There's 3 levels. But some of you are probably faster than this, and you'll probably finish before that. So that way you know. So if you're taking longer than 40, that means, we need to somehow be faster. And then a UH quiz. I'll put it on Canvas eventually. Attempt by tomorrow, but do the spooky day or day before spooky. Cool or not cool, guys? All right, we're done, guys. I hope you guys are happy.